In this video, I will show you some basic matrix vocabulary and operations. For example, problem number 1. DIMA in this context stands for the dimensions of matrix A. And the dimensions are the number of rows by the number of columns. So matrix A has 3 rows and it has 3 columns. So this is a 3 by 3 matrix. By contrast, the dimensions of matrix C, this has 2 rows and 3 columns. So this is a 2 by 3 matrix. In problem number 3, it says find A 1, 3. So this lowercase a means we should be looking at matrix A. And the 1, 3, you know what, let me write this bigger. A 1, 3. This means row 1 and column 3. So row 1, column 3, that's -2. Okay, what about C2, 1? So that tells us to look at matrix C, row 2, column 1. So row 2, column 1, that is -6. Okay, let's talk about the dimensions of C times B. Well, matrix C has dimensions 2 by 3, while matrix B has dimensions 3 by 3. First of all, let's ask ourselves if this is possible. For matrix multiplication, the inner dimensions have to be the same, and they are. So far so good. But the outer dimensions tell you the dimensions of the product. So that means that matrix C times B, or matrix CB, will have dimensions 2 by 3 because those are the outer dimensions. Okay, what about the dimensions of matrix A times matrix C? Well, let's do our analysis. Matrix A has dimensions 3 by 3, while matrix C has dimensions 2 by 3. Uh-oh, I see a problem. Do you? The problem is this. The inner dimensions have to be the same in order for this to be possible. But the inner dimensions are 3 and 2. They do not match, so this is undefined. Okay, so we can't say the dimensions because it's undefined. Sort of a trick question, but not much of a trick question. Okay, what about problem number 7? So now we're going to perform some operations if possible. We're going to do B times C first. So here we are about to multiply matrix B times matrix C. First, we need to do our dimension analysis. So matrix B, again, is a 3 by 3 matrix. Matrix C here is a 2 by 3 matrix. The inner dimensions must be the same. So, immediately, this is not possible because the inner dimensions are not the same. For number 8, we will do matrix C times matrix B. Again, we must start with our dimensional analysis. Matrix C is a 2 by 3 matrix, 2 by 3. Matrix B is a 3 by 3 matrix, 3 by 3. So first we ask ourselves if this is possible. The inner dimensions have to be the same, and they are. So that's great. So far so good. In addition to that, we know what the dimensions of the answer will be because that comes from the outer dimensions. So the product of C times B will be a 2 by 3 matrix. We need that information right now because we need to set up a 2 by 3 matrix in which to work. So I'm going to make a giant 2 by 3 matrix. So 2 rows, 3 columns. Here we go. I'm setting up a giant 2 by 3 matrix. Told you it was going to be big. Okay, so here's a giant 2 by 3 matrix, and I will show my work in that thing. So as I do this problem, my rows are all going to come from the first matrix, and my columns will all come from the second matrix. Did I leave out that N again? You know what? While I'm at it, let me change this color. I always leave out that N because it feels silent. Okay, so the rows will come from the first matrix. So notice that the first row is 8, 0, 1. So I'm going to put the first row across the first row. So I'm going to put 8, 0, 1 in every one of these spaces. Now don't be alarmed, even though it's a row, I'm going to write it vertically. But that just helps me do my calculations more easily. Alright, but the bottom line is the first row goes across the first row. Now the second row goes across the second row. So I'm going to put -6, 4, 3 across the second row. Okay, so that's it for the rows. Now I'm going to switch over to columns. The first column is going to go down the first column. So -3, 0, 1, and this is all multiplication. Okay, the second column will go down the second column. So -2, 5, 2. And finally, the third column will go down the third column. So 1, 5, -1. Okay, so this is multiplication like I said, so it's time to do this multiplication. 8 times -3 is -24. This is going to give me 0, and this is going to give me 1. Add them up, and I'm going to get -23. Okay, I think I'll do the rest of these off camera because you get the idea. Okay, so in each case we got these numbers right here. So all I did was I multiplied and then I added the result. Now the numbers in these little boxes represent the final answer. So the final answer will be the matrix -23, -14, 7, 21, 38, and 11. So this is the final answer for the question matrix C times matrix B. So for problem number 9, we need to multiply matrix A times matrix C transpose. That's what that T means. Now, what is matrix C transpose? Well, first of all, here's matrix C right here. Matrix C transpose means all of the rows will become columns, and all of the columns will become rows. So see how row 1 is 8, 0, 1? In C transpose, that will be column 1. So I will have 8, 0, 1. See how row 2 is negative 6, 4, 3? That means column 2 will be negative 6, 4, 3. So this is C transpose. Alright, so now let's do our dimensional analysis to see if this is even possible. Matrix A is a 3 by 3 matrix. Matrix C transpose is a 3 by 2 matrix. For this to be possible, the inner dimensions must be the same, and look at that, they are. So this is possible. The outer dimensions tell you the dimensions of your final answer. So I know the outer dimensions, I know that the final answer will have dimensions 3 by 2. So I need to set up a giant 3 by 2 matrix right now. Okay, so that's what I'm going to do. So that means 3 rows and 2 columns. Okay, so here is my giant 3 by 2 matrix setup. And this is where I will do all my work. Okay, when I do this process, all my rows are going to come from the first matrix, and all of my columns will come from the second matrix. Alright, we're going to be multiplying rows times columns. So let's set it up. Look at row 1. Row 1 will go across row 1. So I'm going to write 2, 3, negative 2. 2, 3, negative 2. Yes, even though it's a row, I wrote it vertically. That's just so that when I do my calculations, it will be easy to do. Now here's row 2. Row 2 will go across row 2. Makes perfect sense. So 1, 4, 5. 1, 4, 5. Now row 3. Row 3 will go across row 3. So 0, 1, 7. 0, 1, 7. Easy peasy lemon squeezy. Now let's do the columns. Here we have column 1. Guess what? Column 1 goes down column 1. So let's see. So I'm going to have 8, 0, 1. 8, 0, 1. 8, 0, 1. And finally we have column 2. And yes, you guessed it, column 2 goes down column 2. So negative 6, 4, and 3. And this is all multiplication. So it's time to do that multiplication that I have set up right now. Okay, so 2 times 8 is 16. 3 times 0 is 0. And negative 2 times 1 is negative 2. Then I'm going to add those up, and that's going to give me 14. So I'm going to do the same thing off camera with all of the rest. Okay, so as you can see, I got these numbers here in the boxes. And those numbers in the boxes represent the final answer. So the final answer will be 14, negative 6, 13, 25, 7, 25. So this is it. This is the product A times C transpose. For number 10, we need to do 2 times matrix B minus 3 times matrix A. This is called scalar multiplication. You can multiply a matrix by a number, a scalar, by just multiplying each entry by the scalar. So if I do that, I'm going to get -6, -4, 2, 0, 10, 10, 2, 4, -2. Alright, similarly, I will multiply all of these numbers by 3. So that's going to give me 6, 9, -6, 3, 12, 15, 0, 3, and 21. So all that's left is to subtract these two matrices from one another. We'll just subtract each corresponding entry. So -6 minus 6, that's going to be -12. -4 minus 9 is -13. 2 minus -6, be careful. 2 minus -6, that's a double negative. This is really like 2 plus 6. So that's why we will get 8. 0 minus 3 is -3. 10 minus 12 is -2. 10 minus 15 is -5. 2 minus 0 is 2. 4 minus 3 is 1. And -2 minus 21 is -23. So this is the final answer. For number 11, we need to do b squared. A common mistake would be to take matrix B and just try to square everything inside. It doesn't work that way for matrices. B squared means B times B, so that's what we need to do. So first we need to see if this is even possible. So B is a 3 by 3 matrix. So these are both 3 by 3. This is only going to be possible if the inner dimensions are the same, and which they are. So great, that means it's doable. We need to know the dimensions of the final answer, and for that we will look at the outer dimensions of 3 by 3. Now that we know that the final answer will be a 3 by 3 matrix, let's set up a giant 3 by 3 matrix in which we will do our work. So that's what I'm doing right now. I'm setting up a giant 3 by 3 matrix. Okay, I'm somewhat limited in my spaces. I'm going to do the best I can. Okay, that's going to have to be good enough. Actually, maybe I'll just move this over just a tiny bit. Okay, this is where I will do my work in this giant 3 by 3 matrix. Remember that the rows will come from the first matrix and the columns will come from the second matrix. Okay, so the way it works is we will multiply rows by columns. Row 1 will go all across row 1. So I will have -3, -2, 1. Row 2 will go all across row 2. So I will have 0, 5, 5. And row 3 will go all across row 3. So I will have 1, 2, -1. Okay, almost forgot one. 1, 2, -1. These rows will be multiplied by these columns. So multiplication. So I went ahead and just put in all my multiplication dots. So time for the columns. So column 1 will go down column 1. So negative 3, 0, 1. Column 2 will go down column 2. So negative 2, 5, 2. And column 3 will go down column 3. So 1, 5, negative 1. Alright, and then we will multiply these together and add the result. I'll do one of them here in front of you to make sure you have it, but then I'll do the rest off camera. So negative 3 times negative 3 is 9. Negative 2 times 0 is 0. 1 times 1 is 1. If I add all these up, I get 10. Okay, so I'll do the same thing with the rest of these. Alright, so as you can see, these are the rest of the answers that I got. And these numbers in the boxes make up the final answer, which I have rewritten here. So this matrix right here is the product, well, b squared, b times b. Alright, this will be the last problem on this video. We got some variables sprinkled into this matrix equation, and we need to figure out what they are. So just understand that each corresponding entry must be equal if these two matrices are equal. So for example, that means that 4x must equal 20. So that's something we can write down. 4x must equal 20. That can be solved immediately because we can just divide both sides by 4. So obviously x is equal to 5. So keep that in mind. Now 4y minus 4 must equal 8. Okay, so we would add 4 to both sides. So 4y must equal 12. Dividing both sides by 4, we get y equals 3. Okay, how about z? 12 must equal 6z. So obviously if we just divide both sides by 6, we end up with z equals 2. So in the end, we have 5, 3, and 2. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.